Welcome to Module 201B on AC Fundamentals. We're going to be reviewing some generator theory from first year. Now remember, in first year, most of what we did was based on DC theory. However, everything we do in second year is going to be based on AC theory. So we're going to look at some new forms of resistance and some of the other aspects of what the difference is between DC and AC. And this particular module is split into 5 different objectives, and we're going to split those objectives into 5 different videos as well. This video is all about the generation of an AC sine wave. Voltage generation happens whenever we have a conductor passing through a magnetic field. We get what's called induction. Now, the amount of voltage induced is dependent on a few different factors. First of all, how strong is that magnetic field? The stronger the magnetic field, the more lines of force that magnetic field carries. So that's better for us for voltage production. Also, how quickly can we move that conductor through the lines of force? The faster that we can go through the lines of force, we can also produce more voltage that way. The next thing is also how much conductor is in there cutting lines of force. If we increase the amount of conductor that's inside the magnetic field, then I'm also cutting more lines of force that way as well, and I will generate more voltage. And lastly, it's the cutting angle. At which angle does that conductor cut? Depending on the angle that that conductor is going through that magnetic field, it will produce different amounts of voltage. For example, if my conductor were to travel parallel to the magnetic field, it's not actually cutting any of the lines of flux. Therefore, I don't get any generation. I have to have that interaction between the conductor and the lines of force. If there's no interaction, there's no voltage being created. So if I take that same conductor and approach the same lines of force at a 45-degree angle, I'll be producing much more voltage than at a parallel. However, I'm still not producing the maximum. The point to which I produce the maximum amount of voltage is if I were to cut them at 90 degrees. The reason for this is that now my conductor is cutting as many lines of force as quickly as it possibly can. Therefore, we get a peak production of our voltage. Now consider how a conductor rotates through magnetic lines of flux inside a generator. It's always changing direction. As it goes up and around the circle, it's always going to be producing different amounts of voltage as well. Anytime that I pass by the 0 degrees on my sine wave, for example, it's also the same point that my conductor is running parallel to the lines of force. There's no generation, therefore it's at the 0 point inside my sine wave, and that happens twice. It happens on one side and then on the other side, at 0 degrees and 180 degrees. Now as I go from 0 degrees on my rotation up towards 90 degrees on my rotation, I'm also cutting more and more lines of force as I change the cutting angle. And at 90 degrees, that's where I'm directly perpendicular to the lines of force. And that's where I'm going to see my peak. And I have 2 peaks as well. One peak is on the north side at 90 degrees. The other peak is on the south side at 270 degrees. The difference is when I cross the 180-degree line, I change from a positive generation to a negative generation. And this all has to do with Fleming's left-hand rule, where the current created by this is all dependent on the direction the conductor is cutting the lines of force. So as I change the direction, first I'm going from right to left, and on the second half I go from left to right. As I change that direction, I also change the polarity. So this is how my sine waves are going to be created. Passing a conductor in a circle through a magnetic field, I'm going to create different types of voltage all the way through it, as well as I'm going to be changing polarities halfway through. Every cycle has 2 zeros, where my voltage being created is at 0, and every cycle has 2 peaks, one positive peak and one negative peak. So each time the conductor passes a pole, that's considered to be one alternation. So when I go from 0 to 180 degrees, I pass by the North Pole, that is considered to be one alternation, and as I go from 180 degrees back up again to 0 on the negative side, that's considered to be a second alternation. So I can have 2 alternations back to back, one positive and one negative. And both those 2 alternations put together is what we call an electrical cycle. This creates 360 electrical degrees of generation. So that's the end of part 1 on how sine waves are produced. Return to Blackboard and complete the knowledge check, and then continue on to 201B Part 2.